So nothing changes. There's still parabolas. We still have vertex intercepts, all of that. It's just that right now we're going to attach meaning to every single point. So the path of a baseball that has been hit can be modeled by the following equation. There's your equation, where h of t is the height in feet and t is the time in seconds. Now we're never going to make this up, but these variables are now t, right? You're normally used to x. So, but that's still our x variable. We just call it t right now. It's going to be along the x-axis. So we used to call it x and y. What is x now in this context? X is t, right? This is the x value, so it's t for time. And h of t, right? This used to be where the y was located. Okay, so I'm going to call that y. So we will now refer to every single point as the time after the ball got hit and the height at which the ball is at, right? So time goes with height. So every single point is going to tell us these two pieces of information. No longer x and y without context, okay? All right, so A. What is the initial height of the trajectory of the ball? In other words, at what height was the ball hit? Where is this found? Initial height is found at the y-intercept. Okay? So in a sense, I'm going to make a little sketch. I actually would encourage you to do that every time you have a word problem. Just do a little sketch on the side so you can kind of picture what's going on. So this is your time. This is your height. You don't get any marks for this. It's just to understand it, right? Based on this equation, is this ball, where is it starting? Is it starting on the ground? Or is it starting off the ground? Let's look at this. What does this tell us? Like, that's the y-intercept, correct? So the y-intercept is what? 0, 4, correct? This is time, and this is height. Remember? So at time 0, you're at a height of 4 feet. So please don't answer it like this. You will say 4 feet is your initial height and circle it. Some teachers make you write a full-on sentence. I'm not too picky on that because the province would be okay with you clearly indicating 4 feet. If you just gave us that, it's not good enough because we don't know if you know, is it 0 or is it 4? What is it? Okay. So state the coordinate of the y-intercept and then this. So we know that this is starting at 0, 4. And then the ball will be hit, right? And then possibly hit the ground. That we don't know. We're going to have to read a little further. But this is your initial height, okay? Without even typing this into our calculator, we were able to answer that. Determine the maximum height of the ball. Where would that be found? Found at the vertex, right? So can we just get it off of the equation? It's not in vertex form, is it? We have to use our calculator. So let's go ahead and do that. I will just tell you this. If I give you an equation or the province gives you an equation, just type it into Y1. Like just go for it already. It's almost a no-brainer. So I'm going to type that in. Just make sure you do this right. And you don't have a t variable, just it's x, right? So I type that in, and then I hit graph. And in this case, I don't really care about these quadrants here. So I'm going to reduce those, the y-min, x-min, maybe go a zoom standard. I'm going to go a zoom standard here. Doesn't change a whole lot. Let's chase the curve here. So I'm just going to go window. In this case, I'm going to try y max. I'm going to try 50. Still not high enough, right? We need to go a little higher. Let's go 80 for Y max. And there it is. You can see the vertex. So all I've done is I changed my Y max until I could see the cap, and I see the x-intercepts here and here and the y-intercept, so we're good to go. So let's find the vertex. Second trace what? Min or max? Max, right? Yeah. Go to the left of it. I'm going to hit enter right here because I am to the left. Go across, enter, enter, and there it is. So you got to go second trace max, right? It's not a whole lot of work that I'm asking for. 3.57, 66.5. That's not answering the question yet. That is just the coordinate of the vertex. So the max height is, which one is it? 66.5, right? We've determined that the y value, and and it's measured in feet, so make sure you have your units there. So now we know that this point here is 3.57, 66.5. Okay? So I'm just going to keep a tally because more than likely you're going to be asked to graph this later, and it's nice to just have it there. Even if you need to state your domain and range, it's nice to have this little sketch there. C. What is C asking for? How long does it take the ball to hit the ground? Right? How long does it remain airborne? Hits the ground at the x-intercept. And so it's right here. We're interested in this point right here because we know that that'll give us the time it took to hit that point right there. We know that I can tell you this, the y value is going to be 0, correct? The height, because it's going to hit the ground at that point. So we're going to go grab our calculator. How do we find the x-intercept? We let y2 equal to 0, hit graph. I'm not interested in this one. Remember, it starts at time 0. This x-intercept is possibly over to the left of the y-axis, which we don't care about. You want this one right here. Second trace 5. And that's close enough. Enter, enter, enter. So that is 7.25. So I can translate this within this context saying, hey, it takes 7.25 seconds for the ball to hit the ground. Okay? It takes 7.25, is it hours, minutes, days? What's time in? In this case, it's seconds, right? So there you have it. I'm going to translate that over to my little sketch here. Could you now state the domain and range already? Domain is 0 to 7.25, right? And what about range? 4 to 66.5. Nope. What's the lowest y value? 0, right? This thing does hit the x-axis. So 0 all the way to 66.5. So right there, stating your domain and range is so easy if you have a little sketch. Okay? All right, let's keep going. D. Calculate the height of the ball 1.5 seconds after being hit. What's that saying? What's this? What is that? The height of the ball is what we want. Think of it this way. It's asking for this. If time is 1.5 seconds, what is the height? Okay. That's what this question is asking. What function in our calculator is going to allow us to answer this question? Second trace what? Value. Okay? Value. Because when you select value, it's going to go X and it's going to blink, right? It's going to ask you, give me an X value. What is the X value in this particular case? It's 1.5 seconds. So let's go ahead and do that. Second trace value, and the value we're given is 1.5, right, seconds. So after 1.5 seconds, it reaches a height of 45.48, right, if you round that to 2 decimals. So y is 45.48 feet. E, determine the time, watch this, determine the time the ball remains at or above 49 feet. Okay. How do we do that? Look up here we know, for example, how long the ball stays above the ground, correct? We would just figure it out by knowing how long, right? This is 7.25 right here. We want to know how long it stays at or above 49. So watch what I'm going to do. If you look up here, I'm going to take this red line and bring it to 49. Okay, to have that mark where the 49 feet mark is. So you go to y equals, you let y2 equal to 49, then you hit graph, okay, and you should see the red line is now at a height of 49 feet. So you can visually see that we are interested in the time spent above that red line. Okay, so this is how you do a question like this. It's actually quite popular. We let y2 equal to 49, and we're going to find those intersections, correct? So we're going to go second trace intersect. And I'm going to do a little sketch just for this one. Remember, it's a sketch. It's not drawn to scale. We're going to put the 49 line right here. Let me just bring this up a bit for some of you in the back rows there so you can see it. So I'm going to find out this time. I'm going to call this time 1. And I'm going to also figure out what the time was when it comes back down to 49. So here we go. Second trace 5. Let's find the first one. Enter, enter, enter. A little nuance here. We round to 4 decimals here. You double the decimal places because we're going to subtract these two numbers. So you don't want to round just yet. So I'm going to write this down. 1.6816. Do this one more time. Second trace 5. Travel over to the other side. Enter, enter, enter. That's 5.4613. So 4 decimals, okay? If you want full marks, it's usually a 2-mark question, okay? So we're going to subtract that time. So we're going to go delta t is essentially calling for you to subtract t2 minus t1. And so 5.46, and you can go dot dot, 1.6 dot dot dot, because we're assuming you're using all the decimals here. And when you subtract them, you get 3.78. So I'm going to go delta t is 3.78 seconds. Okay. This answers the question at or above. So you found, right, if I highlight this, right, orange there, you found the time that the ball would spend above the 49-foot mark. Okay. We're going to graph it in a bit. Let's go with G here real quick, the domain and range. So I'm going to I'm going to cut this here a little bit. Can you leave, I'm not going to do that today, but leave some space either next to this or below it. Because I'm going to figure out tomorrow, we're going to do how much time was spent below the 49 line, okay? So we're going to do that tomorrow. I don't want to put too much on you today. G, right here. I'm going to do G right here. What's the domain and range for this scenario? Let's do it right under the sketch if you can. It would be 0 to 7.25 because we're assuming this ball hits, like the action stops when it hits the ground. Right? Let's say we threw a ball into the water or a rock into the water, right? You throw it up and then it lands, like it would keep going down until it hits the ground, right? So then it would change, the situation would change, the graph would change. But in this case, we're assuming that it stops right here. So time from 0 to 7.25 is the only times that we allow in this situation. Let's leave a little bit of space so we can translate that into set notation. Range would be go all the way to 0, right? 0 is the lowest it ever gets to, and 66.5 is the highest we ever get to. Set notation, 0, and I'm going to use t for, how do you know which variable to use, Mr. Dirksen? Like, how do you pick t? You go by the equation, okay? That's what the province tells us. You want to use the letters, so whatever is on the right-hand side, that could be x, y, like, not y, sorry. It could be t, m, d, whatever. You use those letters, okay? And whatever is on the left-hand side, that's our y variable, use the letters that are there. So in this case, it's 7.25. And then it goes here from 0, h, to 66.5. If you go h of t, that is fine as well. So for today, I'm not gonna do h and I'm not gonna do I. Okay? So h and I are still to be determined. I'm gonna say what up with h, right? And I, like what's going on with that later. Right now, I need to do a graph with you before we do that. And I have a grid on the back side of this. So let's go to 37. And just for you right now, I'm going to do the quick sketch here again. Okay, just do this. Doesn't take long. This is 0, 4. Because now you need to sketch. Now you need to make the graph to scale. Okay, this was 3.57, 66.5, and this was 7.250. I think I rounded it incorrectly, guys. My key says 726. Yeah, my bad. Every once in a while, I should make a mistake, right? Just to show that I'm a human being, not a bot. Right? There you go. For a graph, you want to scale intercepts, vertex, label your axes. That's the main idea. So arrowheads along the x and the y axis. Let's call this time and seconds right away. Get that out of your system. This is height and feet. Okay, so now scale. For the x values, I need to include 0 all the way to 7.26, right? So if I went 2, 4, 6, 8, that would work out pretty good. So I'm going to consistently go up by 2s in my markings here. And in terms of my y, I need to make sure I have room for my vertex here, which is 66.5 is the highest y value. So I have to go up by more than, so 20, 40, 60, let's see, maybe it can go up by 10s. Let me see. No. I think I can. It'll be too tight. So I'm going to go up by 20s. But try to use up your grid. Like, don't do this, right? Don't give me a graph like that. Right? Like that's just too small. The scale is not appropriate. So 0, 4. Let's see here. This is 10 right here. This is 5. So 0, 4 should be just under that. 0, 4 is right there. My vertex is at 3.57. So this is 3. 3.57 is right here. And I go all the way to 66. This would be 65. 66 is right there. And then 7.26, I know that this is 7, right in between 6 and 8 is 7. 7.26 is right about there. And then I go vertex, curve out to the y-intercept, vertex, curve out, and you hit the x-intercepts there. And don't forget your equation. It has a beginning and an end, right? This thing. It starts at 0, ends at 7.26. Same with your height. 0 is the lowest. So please do not put arrowheads that continue past, because now you're going against your domain and range. Right? If you had arrowheads, then you must have an infinity somewhere. You don't, right? So be careful what you do there. Okay. I'm just gonna assign two pages. Page 38 to 39, 2 word problems. The nice thing about this is you get to practice domain and range again. I basically ask every time there's a word problem, you can expect domain and range to a certain degree. Okay. And let this help you, okay? So you go back to your notes and you try to figure it out. Will you have some questions? Absolutely, and that's what I expect. Okay. Have a good one, guys.